Hello everyone. On this video we will be looking at a few examples of our hyperbola. Okay, so if you watch the part 1 video explaining how we got all of our formulas and everything else, then you will see that this is the same sheet from that video, so hopefully you have it all written down and a copy of it, but if not, you can always copy it from here. Okay, so here's just give you the top half. So if you're still writing this top half, you can press pause and write this and draw it and get everything up here. Alright, so if you press pause and you've already written this down, you can go on up, and now you can press pause and get the rest of it written down. Alright. Now remember, you have your horizontal vertices and your vertical vertices. So depending on which one you have, based on the formula here and this formula here, depending on which one you have, that's going to determine which formulas you use. Alright, so once again, if you're still writing, feel free to press pause, but we're going to go ahead and move on to our first example. Okay, so we're going to find the vertices and foci of the hyperbola x squared over 16 minus y squared over 36 equals 1. Alright, so first thing we're going to do is we're going to rewrite it, because we can't really get anything from that except the fact that it's centered at the origin, because it's x squared and y squared, not x plus or minus something squared, or y plus or minus something squared. Okay, so we're going to rewrite it. So you have x squared over 16, which is 4 squared, minus y squared over 36, which is 6 squared, equals 1. All right, what does this tell you? Well, same thing it told us up here, but with a little more detail. That this is in the form x minus h squared over a squared minus y minus k squared over b squared equals 1. Which means this has horizontal vertices and foci. All right, so in other words, it's a horizontal hyperbola. All right, now since it's in this form and your x is the positive term, or your x squared is the positive term, you know that the value under that, your a is equal to 4, and your b is equal to 6. All right, so once again, we know that x squared is the same as x minus 0 squared. So that means our h is equal to 0. Same thing with our k. Y squared is the same as y minus 0 squared. So our k is equal to 0. All right, so far we know our a, our b, our h, and our k. All right, but the only thing is to find our foci for horizontal vertices. Remember, if it was vertical, you'd have a different formula. That's h plus c k and h minus c k. Okay, so we have our h, we have our k, but we don't have our c. But that can be quickly remedied, because we know that c squared is equal to a squared plus b squared, or c is equal to the square root of a squared plus b squared. Okay, so we know that a is equal to 4 and b is equal to 6. So c is equal to the square root of 4 squared plus 6 squared. Let me clean that up a little bit. There we go. Which means c is equal to the square root of 16 plus 36. Or c is equal to the square root of 52. Oh, sorry. Got to bring that up. There we go. Now we know that 52 is equal to 4 times 13. So it's the square root of 4 times 13, which can be separated. So c is equal to the square root of 4 times the square root of 13, which means c is equal to 2 square root of 13. Okay, so that means our foci, remember our h is equal to 0 and k is equal to 0. So this is 0 plus 2 square root of 13, k, which is 0, and 0 minus 2 square root of 13, 0. So your foci is 2 square root of 13, 0, and negative 2 square root of 13, 0. That's the point of each of your foci, or focus points. All right, now we find your vertices. Now remember, for horizontal hyperbolas, your vertices is h plus a, k, and h minus a, k. Okay, so we know h and k are 0, and our a is equal to 4. So it's 0 plus 4, 0, and 0 minus 4, 0. Just replacing them. Okay, so it's 4, 0, and negative 4, 0, which are the points of our vertices. All right, so I didn't think that was too bad. Okay, so if you are still writing, feel free to press pause and finish up. But we're going to go ahead and move on to our next example. All right, so find the vertices and foci of the hyperbola y squared over 36 minus x squared over 81 equals 1. All right, so what I want you to do on this one is press pause and try it on your own. All right, so assuming you've already solved this one, so let's go ahead and verify your answer. So again, first thing we're going to do is rewrite it. So you have y squared. Now, if you wanted to, which you don't have to, the y squared, you can make that y minus 0 squared over 36, which is 6 squared, minus x squared, which is x minus 0 squared, over 81, which is 9 squared, equals 1. Like I said, this way you don't have to do it, but it kind of reinforces that it's centered at the origin. Okay, so that means it's in the form, since your y term is first, y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, so what does that tell us? That tells us that our a is equal to 6, our b is equal to 9, our h and k, well in this case h and k, are both equal to 0. So you know it's centered, your center, which is hk, is 0, 0. So we know that h is equal to 0 and k is equal to 0. Okay. Now, we also know from the previous example that we may have our A, we may have our B, but we're going to need our C to find the foci. Okay, so we know that C squared equals A squared plus B squared, or C is equal to the square root of A squared plus B squared. Okay, A is 6 and B is 9, so that means that C is equal to the square root of 6 squared plus 9 squared. So C is equal to the square root of 36 plus 81. Or C is equal to the square root of 117. Okay, so 117 is actually 9 times 13. So that's going to equal to the square root of 9 times 13, which is equal to the square root of 9 times the square root of 13, which is equal to 3 square root of 13. Okay, so that's your C. Okay, so we have our A, our B, our C, our H, and our K. Okay, so we have everything we're going to need to find our foci and vertices. All right, so your foci, remember for your horizontal vertical, is H, K plus C, and H, K minus C. Okay, so that's going to be 0 and 0 plus 3 square root of 13. 0 and 0 minus 3 square root of 13. So your foci will be at 0, 3 square root of 13, and 0, negative 3 square root of 13. All right, now we find our vertices. Okay, so remember for your vertical hyperbola, H, K plus A, and H, K minus A. So it's going to be 0, 0 plus 6, since your A is equal to 6, and 0, 0 minus 6. So the points for your vertices is actually 0, 6, and 0, negative 6. All right. Okay, so if you are still writing this, of course, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so we're going to identify the asymptotes of the hyperbola x plus 2 squared over 16 minus y minus 2 squared over 36 equals 1. All right, so once again, I want you to press pause and try to do this one on your own. Remember, first thing you have to do is identify whether it's vertical or horizontal hyperbola. Okay, so go ahead and press pause and try it on your own. All right, so assuming you are all done, let's go ahead and verify your answer. Okay, we're just going to rewrite it. Now remember, and this is an important step to avoid making mistakes, we see here that our x is in the first term. So it's in the x minus h squared over a squared minus y minus k squared over b squared equals 1. It's in that form. but we have a plus sign here. So remember, you can't have a plus sign in here when you're trying to find the values of your h and k. Okay, so we have x minus negative 2 squared over 16, which is 4 squared, minus y minus 2 squared over 6 squared equals 1. Okay, remember, if you place your h value as being 2, it will throw off all of your equations afterwards. Okay, so that means your a is equal to 4, your b is equal to 6, this is your h right here, and this is your k. So your h is equal to negative 2, and your k is equal to 2. So we have all 4 of those just from the fact that we know this is a horizontal hyperbola. Okay. Now, to find our asymptote for the horizontal hyperbola, we know that it's y minus k equals b over a x minus h, and y minus k equals negative b over a x minus h. All right, so what we're going to do is we're going to go ahead and just add k to both sides for both of these, really just to help us solve for y. So it's y equals b over a x minus h plus k, and y equals negative b over a x minus h plus k. Okay, so we know our b, our a, our h, and our k, all from up here. So we go ahead and we plug those in. So you have y equals 6 over 4, since that's our b over a, x minus h, so x minus negative 2, plus k, so that's plus 2. And y equals negative 6 over 4, x minus negative 2 plus 2. All right, so we can go ahead and simplify this fraction. So we have y equals 3 over 2 times x plus 2, since we have the minus negative, plus 2, and y equals negative 3 over 2, x plus 2 plus 2. So those are your asymptotes. All right, so just for a second, I'm going to go back to the very first page to show you what those would represent. Okay, so for the horizontal vertice, remember your asymptotes are the two lines that your parabolas just won't cross. So you have this parabola and this parabola. So your hyperbola will not cross those lines. Those are your asymptotes. All right, so if you are still writing, of course, you feel free to press pause and finish up. But we're going to go ahead and move on to our next example. Okay, so with this one, you want to find the equation of hyperbola. Let's say standard equation, to be a little more specific. Okay, so you want to find the standard equation of hyperbola with the vertices at negative 5, 1, and 1, 1, and your foci at negative 9, 1, and 5, 1. All right, so once again, I want you to press pause and try this one on your own. All right, so let's go ahead and verify your answer. Okay, so the first thing I would do when given those points is I would make a little mock sketch. And vertices. And this one quick step kind of gives you an idea of what you're working with. Okay, so right here, if you make a quick little sketch, like I said, it doesn't have to be accurate. It's just something to help you visualize. So if you get negative 5, 1, and 1, 1, okay, so we go negative 5, 1, and plus 1, 1. So this is negative 5, 1, and this is 1, 1. Okay, we can see there that our vertices are horizontal. Also, with our foci, we go negative 9, 1, and 5, 1. So negative 9, 1, and 5, 1. We see that our hyperbola will look something like that. Just from a quick sketch. Like I said, it doesn't have to be accurate, but it does let us know that this is a horizontal hyperbola. And just knowing that, we know now that we will work around the equation x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, so just plotting those points gave us that idea. So now we know what we're working with. We know what we need. Okay, so first thing we're going to do is we need to find our h and our k. Okay. Well, this is where knowing the concept comes in handy, because we know that the center is in between the vertices. Okay. So the center is the midpoint of the vertices. And it's also right in between the foci too, but I'm just doing the vertices because it's right there. So if we get our midpoint formula, remember that's x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, so if we make this our x1, y1 and this x2, y2, or it doesn't matter which one you make which one. Okay, so we have our x1 and x2, so we have 1 plus negative 5, 1 plus negative 5 over 2, and we have 1 plus 1 over 2, our y1 and our y2, 1 plus 1 over 2. Okay, so that gives us negative 4 over 2 and 2, 2. So that means your midpoint, which in this case is your center, is going to equal negative 2, 1. Negative 4 divided by 2 is negative 2. 2 divided by 2 is 1. Okay, so since this is our center, we know that our h is equal to negative 2, and our k is equal to 1. Okay, so we have our h and our k. So all we have to do now is find our a and our b. Okay, now the one thing we can see here, just using this, is we know also that your transverse axis equals 2a. You kind of separate that a little. Okay, so your transverse axis is the line right between your two vertices. That's your transverse axis. And we know that's equal to 2a because this from the center to this vertex is a, the center from this vertex to a, so the whole thing is 2a. Okay, so if we can find the difference between -5 and 1, we know that will equal 2a. So that means that our x equals -5 and x equals 1, we have to find the difference. So 1 minus -5 will equal 2a. Okay. So that means 1 minus -5, so that's 1 plus 5, so 6 equals 2a. Divide both sides by 2. A is equal to 3. Okay, so we were able to find that one. Now we just have to find our b. Okay, the only thing is we don't exactly know where the points for our co-vertices are. So we're going to have to go kind of a roundabout way. Okay, we can't just go ahead and plug in our co-vertices or anything like that. We have to go kind of a roundabout way. All right. So to do that, something else we have to remember. The distance from the foci to the center is equal to c. Now, you have two foci. Okay, remember your center is hk. You have h plus c and h minus c. Okay, now since it's horizontal, we know that your h plus c has to equal 5, because that's the x value, and your h minus c has to equal -9. Right? You really only need one of these because you'll get the same answer for each one. Okay, so let's say h plus c equals 5. And just to show you, I'll do both of them just to show you that either one would work, where you wouldn't have to do both. You only have to use one of these. So remember, our h is equal to -2. So that means -2 plus c equals 5. Add 2 to both sides. C equals 7. Now remember, h is equal to -2. So for this one, -2 minus c equals -9. Add 2 to both sides. -c equals -7. Divide or multiply both sides by -1. And that gives you c equals 7. So you don't have to use both. All you have to do is find one foci and make it either h plus c or h minus c. Okay, so now we have our c, and we can use that to find our b. Since we have our c and we have our a. Remember that c squared equals a squared plus b squared for the hyperbola. But if we subtract a squared, b squared is equal to c squared minus a squared. Or just b is equal to the square root of c squared minus a squared. Okay, so we know that c is equal to 7 and a is equal to 3. So b is equal to the square root of 7 squared minus 3 squared. Which means that b is equal to the square root of 49 minus 9, which is the square root of 40. And if we simplify that, actually we'll leave it a square root of 40. instead of making that 2 square root of 10, we'll just leave it square root of 40 because we're going to use it almost immediately. All right, so we're basically running out of room on this page. So if you're still writing, feel free to press pause, but we're going to go ahead and move on to the next page to finish this up. All right, let me straighten up my papers here. There we go. There we go. Okay, so just to continue this, remember we have x minus h squared over a squared minus y minus k squared over b squared equals 1. So if we plug everything in, our h, our k, and our a, and our b, that's x minus negative 2 squared over 3 squared minus y minus 1 squared over square root of 40 squared equals 1. Okay, so that means you have x plus 2 squared over 9 minus y minus 1 squared. Square root of 40 squared is just 40 equals 1. And that's your standard equation. All right. So if you are still writing this, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our last example. And this is where we want to find the standard form of the hyperbola, 9x squared minus 54x minus 25y squared plus 100y minus 244 equals 0. Okay, now this is the general form. You want to convert that to the standard form. All right, so once again, if you think you know how to do it, go ahead and press pause and try to solve this one on your own. All right, so assuming you've already pressed pause and tried it if you were going to, so let's go ahead and verify. Okay, so your very first step is you want to make sure all variable terms are next to each other. Okay, so you want the x's next to the x's and the y's next to the y's. And the constant is isolated. Excuse me. Okay, so we're going to go ahead and rewrite it. Again, this one you don't have to worry about it because you have the x squared next to the x, so you're already good. So you have 9x squared minus 54x. Okay, because sometimes you may have an x squared here and an x down here. You want to put the x terms next to each other. Okay, minus 25y squared plus 100y. We're going to add 244 to both sides. So if we add 244 to this side, those two will cancel out, and this will equal 244. Okay. Now for this one, we're going to factor out the constant for the common variables. Okay, so in other words, we're going to factor out the constant for those two. We're going to factor out the constant for those two. Okay, so for these two, we can actually factor out a 9. So we have 9 times x squared minus 6x. And for these two, we can factor out a negative 25 minus 25 and y squared minus 4y equals 244. Okay, so we're going to rewrite this, but we're going to have a little bit of space after this because our next step is to use completing the square. Okay, so we're going to go ahead and rewrite it and use completing the square. So we have 9 times x squared minus 6x, and give it a little bit of space, minus 25 times y squared minus 4y, give it a little bit of space, equals 244. And kind of put a little square around those to separate them. Okay, so we're going to use completing the square on both of these polynomials. Okay, so we know here that a is equal to 1, b is equal to negative 6, and completing the square is equal to b divided by 2a squared. So our b is negative 6 in this case, so that's going to be negative 6 divided by 2 times a, or 2 times 1, which is 2 squared. So this is going to equal negative 6 divided by 2 is negative 3. So it's negative 3 squared, which is equal to 9. Okay, so we're actually going to put plus 9 right here. Same thing here. Our a is equal to 1. Our b is equal to negative 4. Remember, completing the square is b divided by 2a squared, which is negative 4 divided by 2a, 2 times 1, which is 2, squared, which is equal to negative 4 divided by 2 is negative 2, so that's negative 2 squared, which is equal to 4. So we're going to put 4 there. All right, so we want to just rewrite it because we're still not done yet. You have 9 times x squared minus 6x plus 9 minus 25 times y squared minus 4y plus 4 equals 244. Okay, now that's all fine and dandy for the left-hand side because we filled this in. But by filling this in, we change the value, because if you distribute this 9 to all of those, you should end up right back here. 9x squared minus 54, well, it should be right here, those two terms. 9x squared minus 54x. But we're not at that. We have 9x squared minus 54x plus 81. By putting that 9 there, we added 81 to this term. So just to balance it out, we have to add 81 to the right-hand side. Same thing here. If we distribute this 25, we have negative 25y squared plus 100y, and then by adding that 4 there, it's another minus 100. So to balance it out, we have to put minus 100 on the other side, because everything we do to the left side of the equal sign, we have to do it to the right. So now we go ahead and we add those together. But remember here, the thing about those is that by completing the square, we created perfect square trinomials. So we can rewrite those. So we have 9, and this can actually be factored into x minus 3 squared minus 25. This is a perfect square trinomial, and that's y minus 2 squared equals 244 plus 81 minus 100 is equal to 225. Okay, so now we want to divide every term by 225. All three terms, this one, and this one. So if we do that, we have 9 times x minus 3 squared over 225 minus 25 times y minus 2 squared over 225 equals 225 divided by 225, which is equal 1. Okay, so now we can go ahead and simplify these. Okay, so if we simplify 9 over 225, we actually get 1 over 25. So we have x minus 3 squared over 25 minus 25 divided by 225 is 1 over 9. So we have y minus 2 squared over 9 equals 1. And this is your standard form. All right. So hopefully this all made sense, and I will see you on the next video.